What's up, guys? Second video on calculations. This is something that people find like surprisingly difficult, um, but it's no different to different things that we talk about. So here, a beautiful picture of a dozen eggs, of course, and then a single egg. We know, like that's in our vernacular. We talk about that, maybe not all the time, but often we talk about this idea that 12's our number here, right? 12's our number. And to go from one egg to a dozen eggs, we need to divide that by 12. And to go from a dozen to how many eggs, we're going to times by 12. So 12's our magic number here, right? Now, if we've got 2 dozen, very simply, we're going to do our 2 times 12, and we get to 24 eggs, right? And again, the same works the other way. If we've got eggs and we want to know how many dozen that is, all we're going to do is divide our 3 by 12 and see what we get. And what we get is 0.25. Something that's not in our vernacular but still is quite concrete and quite simple to understand is a ream of paper and a piece of paper. This time, it'd be incredible if you knew it, it's 500. So there's 500 pieces of paper inside a ream of paper. So in order to go from ream to number of pieces of paper, we need to times by that 500, right? And then to go in the other direction, we're going to divide by 500. So very simply here, a couple of examples. 2 reams, all we need to do is times that 2 by 500, and we get to our 1,000 pieces of paper. So if we say we've got 2 reams, that's the same as saying we've got 1,000 pieces of paper. If we go the other way, we've got 1,200 pieces of paper, and we want to know the number of reams that is, we're just going to divide by 500, and there we get to 2.4. And Avogadro's constant is exactly the same, okay? Because what we're dealing with when we're talking about moles, we're dealing with crazy big numbers. Crazy big numbers. Let me clear this space for now. We're dealing with crazy big numbers. So this time, 1 mole represents 6.022 times 10 to the 23 atoms, right? That is a huge number. So instead of writing 600 or whatever the number is, so here we're going to have 1, 2, 3, 14, 15, 16, 17, 18, 19, 20. Instead of writing these sorts of numbers out, if we were going to write 1 mole, it's this sort of number that we're writing out every time. So instead of that, we either times or divide by that number to see what we're working with. Okay, so 6.022 times 10 to the 23. So if we're working out the number of atoms or ions or molecules of something, the question will tell us we're going to times by that number, 6.022 times 10 to the 23. A really, really big number. And a really nice thing is if we had 1 mole of basketballs, that would be enough basketballs to fill up the whole of Earth, right? We're talking about crazy numbers here, incomprehensible numbers. And to go the other way, if we've been given the number of atoms or ions or molecules, to work out the number of moles here, let me swap my arrow rounds. All we're going to do is divide by 6.022 times 10 to 23. Okay, so let's put that in action. So this time we've got 3 moles of hydrogen. We're going to work out how many atoms or molecules there are in this case. We're going to work out how many molecules of hydrogen there are. So there we're going to do, and again, it's worth us thinking about our calculator here. All we're going to do here is our 3 multiplied by 6.022 times 10, so this bit, to the 23, right? Equals, and then we get to, for this is 1.806 times 8066, times 10 to the 24. And then sometimes we're going to be asked to go the other way. So we've got 680,000 atoms of helium. So now we're going back the other way. We're dividing by Avogadro's constant. So there again, this is our thing, right? Our 10 times 10x. And then we just have to write our 23. We don't need to worry about subscript, superscript, or whatever. So here, 680,000 divided by Avogadro's constants, and we get to this mad number of 1.13 times 10 to the minus 18. Last one, we've got 5 moles of calcium hydroxide, and this time we need to work out how many OH minus ions we make. So this is interesting, right? Because we've got calcium hydroxide, and in each of those we've got one lot of calcium 2 plus 2 lots of OH minus. So we need to multiply this 5 by 2 here. So we've got 10 moles of OH minus. We're going to multiply that by Avogadro's constants, and then we get to 6.022 times 10 to the 24. Yeah, give these ones a go. Again, similar sort of ideas in terms of the questions from the end of last video. Let's look at these. So sodium here, sodium we've got 23. It's got one lot of 23. It's 23, obviously. Cl2, we've got 2 lots of 35.5. Gives us 71. H2SO4, we've got 2 lots of 1 plus 1 lot of 32.1 plus 4 lots of 16. And there we get to 98.1. And last one, we've got 2 lots of N, which is 14, plus 8 lots of 1 for hydrogen, plus 16. And there we get to 52. And again, let's stay in the habit of circling our answers. See you next time, guys. Happy revising.